Ready.
Oh, hi. So earlier in this section, we used trigonometry to find side lengths and angle measures of right triangles. Now today we're going to perform vector operations geometrically and perform vector operations on the coordinate plane. So some new vocabulary is a vector, and we have a little video for you to describe what a vector is.
This is Tyler. Tyler, with Gregorlick's help, is writing an email to his boss, Anita. Tyler sits just 15 feet away. Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, as I'm committing crimes with both direction and magnitude. Oh yeah!
So that was our friend Vector. So a vector has the magnitude and the direction of a quantity. What? Okay. Magnitude is the length of the vector. The direction is the angle the vector forms with the horizontal between 0 and 90 degrees. And the resultant is the sum of two or more vectors. So we're actually skipping examples 1 and 2 in the homework, but I just want to go over them kind of quickly. So you just kind of know what's going on. So it says use a ruler and a protractor to draw each vector, include a scale on each diagram. Using a ruler and a protractor is probably the least accurate way to do this, but essentially what we're doing is, so it says S vector equals 80 meters at 24 degrees west of north. Well, if you were to actually draw this, you wouldn't want to draw something 80 meters long because that would be super inaccurate. So we would have to find some sort of scale. So they're using a scale of 1 centimeter to 50 meters. And then you can draw the vector. And the picture didn't show up. Alright, that's fine. Maybe the next one will show up. Sorry, guys. Okay, so this one now we have 16 yards per second at 165 degrees to the horizontal. So again, we're not going to draw something 16 yards, so we have some sort of scale. So the scale that they're using is 1 centimeter to 8 yards. So when we divide that, we get 2 centimeters is going to be 16 yards. And we're just drawing an arrow at a 165 degree arrow to the horizontal being that x-intercept. So here's our Here's our x-intercept, and we're going 165 degrees, and this is 2 centimeters long. Okay, this you do the same type of stuff. Okay, so now with vector addition, there's 2 different methods to do that. So here's vector A, it's in blue, and vector B is in red. So if we wanted to add those together, there's 2 different ways to do it. So the parallelogram method is, if we were to have vector A and vector B start at the same point, it would be like if we copied vector B up here at the arrow end of A, and then copied vector A at the arrow end of B, it would create this parallelogram. Then the diagonal would be the sum of the 2 vectors. Okay, now another method over here is to draw vector A first, and then draw vector B starting at that tip of the arrow from A, and then creating your third leg of that triangle. It's the same thing as over here, but just a different way of finding it. So you guys would be able to kind of play around with them and see which method you like better. Okay, so for this one, we have A minus B. So subtracting a vector, B, is the equivalent to adding its opposite. So we would take A or B here and flip it over, which would be negative B. Okay, so there's that negative B. This is like the parallelogram, so we're going to copy A and B and then create its diagonal, and that would be vector A minus vector B. The other method is the triangle method. So first we draw vector A, and then connecting vector A, we draw the opposite of B, and then construct that other leg. And it's the same thing as if we use the parallelogram method, but okay. So here would be another one that we could do. I'm kind of going to skip through it. Okay, so this is the stuff that we're starting the homework on, so this is what we really want you to know. So we have to write the component form of vector AB. So here's vector AB. We're starting at -1, -4, and then the vector is ending on -5, -1. So really what we want to know is how are we getting from A to B? So if we take point B, minus point A, so we're having x2 minus x1 as our x value, and y1 minus, oh my goodness, can't get my words straight, x2 minus x1 for our x value, and y2 minus y1 for our y value. So we go ahead and plug those in, so then we have -5 minus the -1, and -1 minus -4, so we end up with -4, 3. So that would be the component form of that vector AB. Okay, go ahead and pause your video and try this one on your own. Uh-oh, we're missing a picture. Mr. Knudsen, can you show me what the picture's supposed to look like? Or try getting it to load.
Yeah, it won't just show up on here either. Yeah, let's make one up. So what are two numbers that subtract to 2 and then two numbers that subtract to 4?
Just try an arrow like that. Keep it positive.
Yeah, write 2 up 4.
So here, let's just start at 6, 4. And
Okay.
then we would end at 8, 8.
Yep, you got it.
Okay.
That'll work.
So here's one that we just made up on the fly. So let's call this A, B. So here's vector AB. We're starting it with A being 6, 4. And then B, we're ending at 8, 8. So if we take point B minus point A, we would have for an x value 8 minus 6. So we're resulting with 2. And then for our y value, 8 minus 4 is 4. But we need that written like that. So then B is our answer. Alright, fun technology today. Okay, so now we're finding the magnitude and the direction of vector S. So we're given vector S is 7, -5. So we can use the distance formula to find the vector's magnitude, but honestly it's easier to use the Pythagorean theorem. So what they're doing here is they're using the distance formula. They're plugging in the points 7, -5, and 0, 0, which is not incorrect. It's just maybe a little bit more work because we're using zeros, which seems kind of pointless. So essentially we're using the Pythagorean theorem here because we're not actually subtracting anything. So when we plug in 7 and negative 5, we get the square root of 74, which is about 8.6. Okay, so that would be the magnitude. Now we have to use a little bit of trig to find the vector's direction. So we're graphing 7, negative 5, that's that vector. Okay, so it says its horizontal component and its vertical component. So we're going over to the right 7 and down 5. That's where the 7 and negative 5 come from. But we have to use the inverse tangent function because we have to find what this angle here is. Oh my goodness. Okay, anyways, so we have the tangent of theta equals 5 over 7 using that opposite over adjacent. Okay, and then to find what the measure of that angle is, we use the inverse of tangent. So we just go ahead, plug in second tangent 5 divided by 7 on our calculator, and then we should get about 35.5. But remember that in the picture that disappeared, we were starting at the horizontal and going all the way around counterclockwise. So we have to take that away from 360. So the degree is actually 324.5. So the magnitude and the direction. Okay? Okay, so we're finding the magnitude and the direction of vector A, which is given -4, -4. So first I want to draw a picture. Okay, so I'm going to do the coordinate plane. Okay, and just a reminder, we're going to call this 0 degrees, we'll call this 90 degrees, right? 180 degrees, 270 degrees. Okay, and I don't know if you guys have done quadrants before, but this is the first quadrant, this is the second quadrant, this guy is the third quadrant, and here we have the fourth quadrant. Okay, so now we have to draw the vector -4, -4. So I'm just going to go over 4, down 4. Okay, and if I draw this vector, it's going to be like that. Okay, so to find the magnitude, we're using the Pythagorean theorem. So really what we're doing is we know that we went over 4, down 4, so this is -4 and -4. So if we go ahead, plug that into the Pythagorean theorem, we would have our hypotenuse here is c squared equals 4 squared plus 4 squared. That would give us the square root of 32, and the square root of 32, oops, I don't want the square root of 32. C would equal the square root of 32, which is about, let me type it into our calculator here, it's about 5.7. Okay, so that's our magnitude. So we know right now that our answer is not D and it will not be A. Okay, now we need to find the direction. So we're going to use trig like we did in the last one. So we would use, okay, here we have the opposite and the adjacent, so we're using the tangent. So we're just going to say tangent of x, we'll say, equals, okay, now we're doing -4 over -4. Okay, to undo this, we need to use the tan inverse. You scared me when you walked in.
Sorry.
Do I just take the tan inverse of 1 here?
Yep.
So I take the tan inverse of 1 because -4 over -4 is 1. So when I do that on the calculator, I get 45. So we should be getting B. Oh, nope, we got C because we have to take that away from 360. all sorts of fun stuff to remember. Okay, so that was kind of the hard part. This is going to be a little more fun. So some vector operations, we can add and we can subtract and we can multiply by a scalar. So when we add vectors, here we have vector with A and B and C and D. It's just like adding mixed points or ordered pairs. We take like the x value, so the first one, so we have A plus C and then B plus D. Same thing goes for subtraction. If we have A, B, and C, D here and we're subtracting them, our first point would be A minus C, our second point would be B minus D. Okay, scalar multiplication is very similar to stuff that we've already done. If we are multiplying by a scalar, some number, usually represented by K, we just multiply everything in the vector by that scalar. So let's apply that. Okay, so we have to find each of the following. It gives us some numbers for vector x, y, and z, and it tells us to find x plus y. So if I put x plus y, we would have negative 1, 4, plus 3, 1. Okay, I'm going to add these two first, so I would have negative 1 plus 3, comma, these two next, 4 plus, oops, something up here. 4 plus 1. Okay, go ahead, solve those out, so we get 2, 5. So vector x plus vector y is going to result in 2, 5, which is what they got. And then over here they're checking graphically, which we don't really have to do. If you want to, great. Like I said before, probably not the most accurate way of finding your answer. Okay, now they're telling us to take z minus x. So we can solve that algebraically as well. We're going to add a negative x, so we just go through and make the x's negative, or the opposite of what they were. So we have z, adding the opposite of x, so when we go ahead and do that, we end up with negative 1, negative 8. And again, they check it graphically. Okay, now this one we're adding and we have a scalar multiplication. So first we have to take this 2 times scalar or vector y, and then we can add it to the vector z. So we put the 2 on the outside of y, we go ahead and distribute that through, then we can do the vector addition, and we end up with 4, negative 2. And that's what that one would look like. Okay, so here's a couple for you guys to try. Pause your video, work this one out. Okay, so this one we have 3a minus b. So if we took 3a right here, I know that that's going to be 6, negative 3. Okay, and I'm subtracting b, which was 5, negative 3. Okay, 6 minus 5 gives us 1. Negative 3 minus negative 3 equals 0. Oops, that's a 0. So we should be getting D for this one. Okay, so this is where we're using the coordinate planes a little bit more, and the quadrants that I showed you guys and the degrees. Okay, so it says, suppose a person is canoeing due east across a river at 4 miles per hour. If the river is flowing south at 3 miles per hour, what is the resultant speed and direction of the canoe? Okay, so if they're canoeing due east, that means that they're going straight. If we had a coordinate plane, they're going straight east, right? Because this would be north, east, south, west. So we're going due east. So if we wrote a vector for that, being 4 miles per hour, our canoe is going 4 0 because it's not going up or down any. Okay, that's our canoe. Now the river says it's going south at 3 miles per hour, so that would be going straight south. So the vector we would call 0, -3. So we can draw that in, say this is 3, and this is 4. Okay, if we had to find the speed, who do I draw the triangle for?
Draw the,
Oh,
yeah, there you go.
okay,
And then go from
There's
the
our
origin to that end point.
now if we go from the origin to here,
Yeah, perfect.
okay, this is 4 up here, so this would be 5. So really, we're flowing at 5 miles per hour. And that 5 comes from, it's a Pythagorean triple, which is hopefully easy to see. Okay, so we're going at 5 miles per hour. Okay, now the direction, that's where we have to use the trig. So we're finding this angle in here. So we could use really any of them, but we could use the 3 or the 4 probably. So we're giving the opposite and the adjacent. So since we've been using tan, we could find the tan of x equal to the ratio here, the opposite over adjacent, so 3 over 4. Okay, so the tan inverse of 3/4 would be gives us about 37 degrees. I maybe should have just let them do all the heavy lifting. Okay, so here's what we were finding here. So like I said, it was about 37, and the way that we say that is it's about 37 degrees south of due east, which is how we drew our picture. Another way of saying that is if we took 90 degrees minus that 36.9, we would get 53.1, and a different way of saying that is east of south. Think about it directionally. Okay, hopefully that's not too confusing for you guys. Okay, but I think this is our last one. So one very similar to that last one says, suppose a person is kayaking due east across a lake at 7 miles per hour. So our canoe now is going at 70. Okay. And the lake is flowing south at 4 miles an hour. So like the last one, we would have 0, 4. Okay. What is the resultant direction and speed of the canoe? Oops, this is a -4 because we're going down. Should I just draw a picture over here?
Sure.
Okay. Okay, so there's our coordinate. So we're going over 7, say this is 7, and then we're going down 4. Oops. Okay, so our speed is going to be using the Pythagorean theorem here. So if we had c squared equals 7 squared plus 4 squared, that would equal 49 plus 16, so 65. Okay, so that speed going here would be the square root of 65, which is about 8.1, I think it was. And I'll just put miles per hour. Hopefully you guys can see that there. So automatically we know that it's not this one and it's not this one because we know it's going at 81 miles per hour. Now we use that trig to find this angle. So I could use tan theta equals, we're going to use trig, so we have -4 over 7. So we take the tan inverse of negative 4/7, and when we plug that into our calculator, we get about 27 or 29.7. Okay. So hopefully that wasn't too much. Hopefully I did okay at explaining it all. We're going to do page 606, 23 through 47. It's a little bit shorter because remember we skipped those first examples.